Hey, glad you could join us. It's always a little magical to have someone step into this quiet corner of the universe with me. Thanks for taking a moment to slow down, breathe deep, and look up. There's something comforting about knowing we're sharing this starlit journey together, even from different places. Maybe you're wrapped in a blanket, or sipping tea, or lying on your back with your headphones in. However you're here, I'm glad. It's a strange, vast universe, but having company makes it feel a little more familiar. If you like listening to quiet stories about space and stars, please tap the like button. It helps others find this peaceful place too. And if you want to come back for more calm journeys through the universe, please like and subscribe. Enjoy what I do here, and let me know in the comments where you're tuning in from and what time it is for you. It's always fascinating to see who's joining us from around the world. Hey everyone, today we're looking into stars, but not just the usual way. We're going somewhere deep, somewhere strange, somewhere that might just be home already, without us knowing. So go ahead, close your eyes, or just soften your gaze. Take a long breath, and now, let's float. Imagine you and I are gliding through the black velvet of space. There's no ship around us, no gear clanking, no helmets hissing, just silence, deep and infinite. And right away, there's something odd. You might notice the stars aren't blinking. They shimmer, sure, but they don't flicker like they do from Earth. That's because there's no atmosphere here to bend their light. They just shine, pure, direct, honest. We drift past a cloud of gas glowing soft pink and blue, the remains of a star that once burned with more power than we can ever truly picture. Reach out, gently. Feel the soft pulse in the light, like a heartbeat slowed down over centuries. It's not warm, but it's not cold either. It just is. Now, tilt your head back. Over there, past those stars that look almost painted on, is something curious. That wide, dark spot, where light seems to vanish entirely. That's not nothing. That's something. And maybe, just maybe, it's where we live. Not near it, not close to it, but inside it. What if I told you that some scientists, the really curious ones who love to ask the questions nobody expects, have wondered whether our entire universe, everything might be inside a black hole? Strange thought, right? But think about it. Black holes are those places where gravity is so strong, nothing can escape. Not light, not time, not even whispers. But from the outside, they look like nothing. Just a dark patch in the sky. On the inside, though, well, that's where things get weird. Space stretches. Time curls up like a sleepy cat. And the rules? They go a bit fuzzy. Let's drift toward that idea. Slowly. You're floating beside me, and around us, the stars start to bend ever so slightly. Not because they're moving, but because the space between us and them is warping, like a wavy window pane on a summer day. Feel that? That soft tug at your chest? That's not fear. That's curiosity. You're sensing the pull of a question we don't quite know how to answer yet. What is a black hole really like inside? We know what happens when something falls in. It gets pulled, stretched. Eventually it disappears from view, but we don't know what it sees from its side of the story. Maybe it's not the end. Maybe it's the start of something else. Here's the wild part. When a massive star collapses and forms a black hole, it doesn't just make a dead spot. It might make a passage, a whole new space, a new inside, a bubble of its own laws and light and time. Now take a look around. What does our universe look like? It's got a beginning, we call it the Big Bang, and it's expanding, stretching outward like a balloon being slowly inflated. Sounds familiar, right? Because when something falls into a black hole, from our perspective it seems to freeze at the edge. But inside, space could be expanding, fast, endlessly. You might already be inside one, not falling into a black hole, but born inside of it, living inside its stretched bubble. All of us. Galaxies and quasars and sleepy little planets. Everything. That would explain some strange things about our universe, like why it's expanding so evenly in all directions, why there's a horizon we can't see past, and why we feel like there's a sort of edge out there but can never quite touch it. And if we are inside a black hole, then maybe black holes aren't just graveyards. Maybe they're wombs, places where new universes are born, where time begins again. Picture it now, we're hovering just at the center of this great cosmic bubble. Not falling, not spinning, just suspended. The stars curve gently around us. The fabric of space ripples in slow waves, like a sleeping ocean. Reach out your hand. Feel how everything here is moving. Not fast, not slow, just forever. Galaxies twirl like maple seeds. Light slides past us in ribbons. Time hums a quiet tune in the distance, something familiar and strange all at once. The thought tickles, doesn't it? That maybe what we see as the universe is just the inside of something else. That the dark we fear might actually be a beginning, not an end. And you're part of it. You, floating right here beside me, breathing easy in the silence, watching the light bend in slow, sweeping arcs. Feeling, maybe for the first time, how beautiful it is to not know everything, to be small, but to exist. Let's stay here a little longer. There's more to see, more to wonder, more to question gently, like tapping on the surface of a dream. So we're still here, you and I, suspended in this great hush of space. The stars are quiet tonight, not because they're asleep, but because they don't need to shout. Their light has been traveling for billions of years just to reach us, and now we're close enough to feel it brush across our skin. Can you feel that soft glow? It's like being warmed by the memory of something that happened long, long ago. Now, let's look a little deeper. We were wondering, could we already be inside a black hole? And that question keeps turning itself gently over, like a leaf on a calm stream. The more you think about it, the stranger and more wonderful it becomes. Because to really imagine that, we need to understand what a black hole does not just on the outside, but deep inside, where no one's ever been. Here's something that might surprise you. Black holes aren't just big vacuum cleaners in space. They're regions where space itself has collapsed under its own weight. When a star several times more massive than our sun runs out of fuel, it stops pushing outward with heat and light, and gravity takes over. The core shrinks. Then it collapses. All of its mass, all the stuff that made it a star, gets squeezed into a point so small, it defies imagination. That point is called a singularity, and around it, there's an invisible boundary known as the event horizon. That's the part where, once you cross it, there's no coming back. Not because something scary eats you, but because all paths inside lead inward, like trying to walk up a down escalator that's moving faster than you can run. Once you step past the edge, gravity just takes you. But here's the twist. From the inside, you wouldn't feel anything strange as you crossed the event horizon, assuming you were big enough and the black hole was massive enough. For really huge black holes, the kind found in the centers of galaxies, you might drift through the boundary and not even notice. No sudden jolt, no flashing lights, just more space, more time, more falling inward. And that's where it gets fascinating. Because some physicists, people who spend their whole lives thinking about the nature of reality, have looked at the equations that describe black holes and said, wait a minute, these equations don't just describe something falling into a hole, they also describe the birth of a whole new space, a new universe. That's right, a black hole might be the gateway to a completely separate universe, one that expands from the inside, just like ours. It wouldn't be inside in the way we think of things, like nesting dolls or boxes inside boxes. Instead, it's more like a pocket, a self-contained world, a bubble floating in a larger foam of realities. And now, we float here, inside one of those possible bubbles. Look around with me. Do you see how the galaxies are drifting apart? Not slowly either, they're speeding up. The space between them is stretching, like dough being kneaded. That's called cosmic expansion. It's not the galaxies themselves moving through space. It's the space itself that's growing. And the thing is, that's exactly what we'd expect to see if we were inside the kind of space that forms inside a black hole. Inside a black hole, space isn't stable. It's dynamic. It stretches. It flows. It carries everything with it. And there's something more. A black hole, any black hole has a temperature. Not the kind of heat we'd feel on our skin, but a whisper of warmth known as Hawking radiation. It's faint beyond belief. But it means black holes are not eternal. Over trillions and trillions of years they fade, they evaporate, they give back what they've taken. Now imagine, if we are inside one, what does that mean for the fate of our universe? Maybe, far in the future, and I mean far, longer than stars live, longer than atoms hold together, maybe the black hole we live in will evaporate. And what happens then? Do we wink out like a candle? Or do we keep expanding, like a story that refuses to end? You might be wondering now, is there any real evidence for this idea? Are we just floating in a dream? Or does science actually hint at this? Well, the truth is, we don't know. But the clues are there. Let's glide past them together. First, the shape of our universe. It's nearly flat. Not perfectly flat like a piece of paper, but close. That tells us something important. If we were in a chaotic, curved, unbounded place, we'd expect all kinds of distortions. But instead, what we see is smooth, balanced. And a black hole interior, according to some models, would appear just like that. Flat inside, calm, spacious. Second, the cosmic microwave background. That's the afterglow of the Big Bang, still warming the universe very slightly, even after nearly 14 billion years. It's almost perfectly even, like the heat of a blanket pulled tight across the cosmos. That smoothness is one of the great mysteries of physics. Why should everything be so uniform? Well, in some black hole models, that's just what you'd expect. A rapid inflation right after the black hole formed a kind of birth shiver could stretch everything out into smoothness. Third, the lack of an edge. You and I could fly in one direction for billions of years and never hit a wall, never reach the edge. That's because space loops back on itself, or maybe just stretches endlessly. Either way, it feels self-contained, like a room with no walls but plenty of space. And again, that's how things might look inside a black hole. Once you're inside, you're not in a tunnel, you're in a bubble, a universe that curves in on itself gently, with no outside view. Now, let's drift close to a galaxy. Anyone. There are 2 trillion out there at least. This one we're near now is called Messier 87. It's huge, really huge. And right at its heart is a black hole so massive, it could swallow our entire solar system and still be hungry. But what if, and just play with this for a moment, what if our universe is what it looks like from inside a black hole like that? Somewhere, from some parent universe, a star collapsed. It made a black hole. And that black hole didn't just crush matter, it gave birth to us. You and me, floating here now, sharing thoughts about light and dark and what it means to be alive. Reach out again, not to grab anything, just to feel. The space between your fingers isn't empty. It's full of particles, ghost particles, popping in and out of existence faster than you can blink. That's quantum foam, the restless background of space itself. And maybe that foam is the echo of the black hole's boundary, shimmering through our own universe. Are you still with me? Good, because we're not nearly done. Let's glide farther, past the galaxies, past the clusters, out toward the deep dark, the place where everything seems to end the cosmic horizon. It's not a wall. It's more like the farthest shore you can see before the ocean curves out of sight. And we wonder again, what lies beyond that edge? Could it be another universe, tucked into another black hole? Or maybe it's just more of the same infinite space, infinite stars. But the black hole idea gives us something beautiful. It makes the universe feel connected, not isolated, not random, but part of something larger, like a raindrop inside a cloud, like a story inside a book you haven't finished yet. Take another breath with me. Long, slow, let the thoughts settle. If our universe was born inside a black hole, then maybe black holes aren't the monsters we thought they were. Maybe they're gardeners, planting seeds of light in the dark, quietly, gently, patiently. And if that's true, then somewhere, maybe right now, in a black hole we've never seen, a new universe is beginning. Maybe someone's floating there, wondering the same things we are. And maybe they'll find this quiet little story, drifting through the stars, and know they're not alone. We haven't reached the edge yet. In fact, maybe there is no edge, just more wonder, unfolding quietly, like pages in a book written by the stars. You and I, we're still drifting, still weightless, still surrounded by the soft hush of everything. No ticking clocks, no hurrying footsteps, just the pulse of space and time, stretched thin like a breath you hold without noticing. Let's look out there again. See that faint smudge? That's a galaxy cluster, thousands of galaxies bound together in a gravitational embrace. They're not scattered at random. They form filaments, cosmic webs, long strands of galaxies stretching across billions of light years, glowing faintly in the dark. This great structure, the cosmic web, is the skeleton of our universe. But even this grand design might be just the inside texture of a black hole's interior. Can you believe that? That all this, these swirls and strands and glowing specks, might be the shape space takes inside a collapsed star? Now let me show you something else. Picture yourself hovering above a spiral galaxy. It's spinning slowly, arms outstretched like it's dancing in zero gravity. At the center of it, tucked deep in the core, is a supermassive black hole. Not a metaphor, a real one. These giants sit quietly in nearly every galaxy's heart, and they're not rare, they're not exotic, they're common, ordinary in the grand scheme of things, like seeds at the center of cosmic apples. And this pattern is curious, because if black holes are always at the center of galaxies, and galaxies are everywhere, and black holes might lead to new universes, then what if each black hole is a kind of cosmic womb? That would mean our universe is filled with possible new universes. Tiny ones, massive ones, gentle ones, wild ones, all hidden inside the dark hearts of stars that collapsed. Now, here's something to stir your thoughts a little more. Let's talk about entropy. Don't worry, no complex jargon here. Just a simple idea. Entropy is how we measure disorder, messiness. The more mixed up something is, the higher its entropy. Now, black holes? They have the highest entropy of anything in the known universe. That's strange, because they look so simple, just dark and round and quiet. But inside, their information content is enormous. Every bit of matter, every ounce of energy, every photon of light that falls into a black hole adds to its entropy. It's like a cosmic library, a place that records everything, but in a language we can't read, at least not yet. And here's the wild part. Our universe has entropy too, a lot of it. So much, in fact, that some physicists suggest this might be another hint that we're inside a black hole. Because the more entropy a space has, the more it behaves like the inside of a black hole. Chaotic, rich with information, bubbling with unseen layers. Look around again. Those stars in the distance? They're not standing still. They're moving. Everything is. Stars orbit galaxies. Galaxies spin in clusters. Clusters drift in the great swell of expanding space. Even now, this universe, our home, is swelling like a balloon in slow motion. And that brings us to something called cosmic inflation. That's the name we give to the idea that, right after the Big Bang, the universe expanded incredibly fast, faster than light. Not because things were moving fast through space, but because space itself was growing. Imagine blowing up a balloon, the surface stretches. If you draw dots on the balloon, they all move apart as the balloon inflates. Now, this is where things get interesting. That rapid inflation? It's very similar to what would happen inside a black hole's event horizon once you pass through. You're pulled inward, but your space might stretch rapidly. It's not you moving through space, it's space changing shape around you, warping, bending, growing. So when we talk about the Big Bang, we might actually be talking about the inside of a black hole coming into being, the moment space cracked open inside the singularity and became a whole new world. And if that's true, then somewhere out there, in a larger universe we can never reach, our entire cosmos is tucked away inside a tiny black dot. Makes you feel small, doesn't it? But not in a bad way. In the same way you feel when you realize how many people there are on Earth, and yet, somehow, your thoughts still matter. Your quiet curiosity, your questions, your sense of wonder. That's what brings meaning to it all. So keep drifting with me. There's more to see, more to feel. Listen closely now, not with your ears, but with your imagination. Do you hear that soft hum, that low, ever-present vibration? That's the background sound of the universe, not real sound, of course, because there's no air out here, but a kind of presence, a rhythm. That's the cosmic microwave background we talked about earlier, the leftover heat from the moment our universe began. It's incredibly faint, just a few degrees above absolute zero, but it's everywhere, uniform, whispering through every corner of space. And if we are inside a black hole, then that background glow might be the aftertaste of the collapse, the lingering heat from the birth of our space. It's comforting, in a way, like a warm memory. Now let's try something together. Close your eyes just for a moment. Picture yourself floating deeper. No gravity, no walls, just the vastness, you and me. And in the distance, something starts to form. Not a shape exactly, but a feeling. This is the boundary of understanding, the place where knowledge fades into mystery. And that's okay. We weren't meant to have all the answers at once. The joy is in the questions, in the floating, in the soft gasp of wonder. Because if we're inside a black hole, then everything we know is just one story, one thread, and there are others, millions of them. Each black hole, a seed, each seed, a universe. And maybe some of those universes have beings like us, dreamers, stargazers, quiet travelers asking gentle questions in the dark. And maybe they're listening now, through some bend in space, catching the echo of our thoughts. Hold on to that idea. Let it ripple through you. Let it settle. We're still here, floating in that silent question. Are we inside a black hole right now? Maybe. But more importantly, look how beautiful the question is. We're floating now through a place that might not have a name, not a galaxy, not a void, just a vastness, deeper than silence, darker than ink, but alive with potential. It's the kind of space you don't fall into. You drift within it, like a dream you don't want to wake from. Somewhere behind us, or maybe ahead, who knows, is the idea that we live inside a black hole, that the universe we know, with its stars and swirling galaxies and lonely comets, might be the inside of something that once collapsed. And that thought, strange as it is, starts to feel comfortable now, doesn't it? Let's go back to the beginning, or at least what we call the beginning, the Big Bang. It wasn't a bang like an explosion, not really. No fiery boom, no pieces flying through pre-existing space. The Big Bang was more like space itself appearing, like a ripple in still water, suddenly growing. Space unfolded, time began ticking, and particles began to dance. But here's the trick: if we are inside a black hole, then what we call the Big Bang could be the moment our pocket universe was born, inside the collapsing core of a massive star, in a parent universe we'll never see. For an observer in that other universe, it might have looked like just another black hole forming, a quiet collapse, nothing unusual. But inside, something vast awakened. That idea fits with something curious about black holes. They have volume. From the outside, they look small, just a sphere with a certain radius, called the Schwarzschild radius. But the space inside? It's much, much larger. That's because gravity warps space in strange ways. A black hole could look tiny from the outside, but contain a whole universe on the inside. And here we are, possibly living in that inside. Now reach out, in your mind. You won't touch stars here, not yet. You'll feel the fabric of space itself, stretching, expanding, not static, not fixed, moving, always. That's something we've measured. By the way, the light from faraway galaxies is redshifted, stretched out, like the universe is breathing outward. We used to think that expansion was slowing down, that maybe gravity would eventually pull everything back together. But in 1998, we found something unexpected. The expansion is speeding up. Galaxies aren't just drifting apart, they're accelerating away from each other. What's causing that? We call it dark energy. But the truth is, we don't really know what it is. It acts like a force pushing space apart, faster and faster. And if we are inside a black hole, that force might be part of the black hole's own geometry, a built-in outward pull, balancing the inward collapse that created it. Let's stop for a moment. Not physically, we're still weightless, still gliding, but mentally. Just breathe in, slow and calm, and consider this. Everything you've ever known, every star you've ever seen, every planet you've dreamed about, might be part of an interior space, a space within a black hole. And maybe the horizon, the limit of what we can see, is the inner wall of that black hole's event horizon. We can't look past it. We can't send signals through it. But from our side, it looks like the edge of the observable universe. Let's float closer to that edge now. You won't hit it. You'll just see things fade, galaxies too far away to ever reach. Their light stretched so thin it may never touch us. That's the cosmic horizon. A soft border made not of walls but of time and expansion. You see, the farther away something is, the faster it appears to recede, because of the space growing between us. And eventually, some galaxies are moving away faster than light can travel. Not because they're breaking physics, but because space itself is expanding beneath them. This too might be a sign that we're inside something larger. Because in many black hole models, the inner region has this exact behavior: space accelerating, light bending, time flowing differently the deeper you go. Now let's feel time. Yes, time has texture here. In deep space, away from gravity, Clocks tick differently, and near a black hole, time stretches. That's not science fiction, it's been measured. A clock near a black hole runs slower than one farther away. If you lived near a massive black hole for a while and then returned to Earth, you'd find that more time had passed here than for you. Now apply that idea to the entire universe. If we're inside a black hole, then maybe time inside isn't running the same as time outside. Maybe our universe's lifespan, billions of years, is just a blink from the outside. Or maybe it's the other way around. You might be thinking, okay, but if we're in a black hole, why don't we see a boundary? Why don't we feel trapped? Well, here's the mind-bending answer. From inside, you can't see the boundary, because space and time are stretched in such a way that the inside becomes its own self-contained realm. It's like being inside a snow globe that's always expanding. You never see the glass, just the swirling snow. But let's go deeper still, not just through space, but into structure. Everything around us, stars, planets, atoms, is made of information. Not just mass and energy, but information. Black holes have a funny property. The amount of information they can contain is proportional to the surface area of their event horizon, not the volume inside. That's called the holographic principle. Now just imagine that our universe is a three-dimensional space, encoded on a two-dimensional boundary we can't see, like a hologram, a projection. That doesn't mean it's not real, just that reality is layered in a way we don't fully grasp yet. You and I, we're part of that projection, walking, breathing stories painted across curved space. And somehow, despite the mystery, it still feels real, because it is. We feel, we wonder, we drift. That's real. Now let's listen again, not for sound, but for pattern. Cosmic background radiation, galaxy formation, the distribution of matter, all of these follow patterns. And those patterns? They match what we'd expect from a space that's expanding from a singular origin, exactly like the inside of a black hole. Still with me? Good, because now, let's go close right up to a real black hole. Don't worry, we won't fall in. Not yet. Look at it, the way light bends around it, the way time seems to freeze at the edge. But inside, that's where this whole story might begin again. Every black hole could be a doorway. Every collapse could be a creation. And if that's true, maybe death isn't the end for stars. Maybe it's just their way of giving birth to new places, new laws, new lives. Maybe you and I are the thoughts of a star that once lived in a universe far away, and when it collapsed, it didn't disappear, it dreamed, and that dream became us. Let your breath fall into rhythm with the stars now. Inhale gently, like drawing in the glow of a distant nebula. Exhale with the patience of a drifting moon. You're weightless, but not lost. You're floating, but not alone. The universe, in all its silence, still seems to be listening. Now look ahead. Just beyond that veil of faint stars, there's a shape you might not recognize. It's not a planet, not a star, not even a galaxy. It's a void, a vast, round region with almost nothing inside. It stretches across hundreds of millions of light years. We call it a cosmic void, and it's one of the most mysterious features of our universe. But here's the part that matters to us. If we are inside a black hole, then these voids might not be random. They might be part of the natural geometry of curved space. The inner space of a black hole isn't smooth. It's lumpy. It's structured. It evolves. These great empty bubbles could be signs of how gravity and space interact when they're stretched to their limits. Drift with me now past the edge of that void. The stars grow thinner here. Light takes longer to reach us. And even though the distance feels endless, time begins to feel soft. Not frozen, but stretched. Imagine pulling taffy between your fingers, the way it thins, the way it drifts between states. That's what time does here. And in this slow time zone, let's consider one more piece of the puzzle. The idea of black hole thermodynamics. Every black hole follows four strange laws similar to the laws of heat and energy. They behave like hot objects, radiating slowly over time. That radiation, Hawking radiation, was one of the biggest breakthroughs in understanding black holes. But here's where it gets weird. If our universe is inside a black hole, then it must obey those same laws. It would have a temperature, a surface, an entropy value, and those things are measurable, and they match. The math, the honest, tested, peer-reviewed math, supports the idea that a universe like ours could exist as the inside of a black hole, born from a collapsing star in a larger, invisible space. The kind of space we'll never reach, but whose touch we feel in every direction. Pause with me now. Don't stop drifting, just pause your thoughts. Feel how strange and comforting it is to think this way. You've always lived here, always moved through this space. But now you're seeing it differently. Not as something outside you, but as something you are inside of. Not a canvas you paint on, but a living structure you float within. Maybe the stars are freckles on the skin of a larger reality. Maybe the galaxies are the neural networks of a dream we're part of. Maybe space itself is alive, not in the way trees or people are alive, but in a quiet, stable, breathing kind of way, always evolving, always unfolding, always containing more than we can know. Now let's turn. Not your body, just your awareness. Look to the side, into a new corridor of thought. Let's talk about the shape of space. Is it infinite? Is it closed like a sphere? Flat like a table? The truth is, we're still trying to answer that. But some clues suggest our universe might be finite, yet unbounded. Like the surface of a balloon, you can walk forever without reaching an edge, but it still has a definite size. This matches exactly what we'd expect inside a black hole. Space bends inward. There's no wall, no fence, but there is a shape. A limit to how far light can travel. A horizon beyond which we cannot see, not because it isn't there, but because time itself won't let us reach it. And speaking of time, let me tell you something stranger still. In some models, the singularity at the heart of a black hole isn't a point in space. It's a moment in time. Think about that for a second. We usually picture a black hole as a sphere, with a tiny dot at the center where everything gets crushed. But if we're inside one, then that dot might actually be the past, the Big Bang, the place all our time flows away from. So, we're not falling toward the singularity, we're flowing away from it. Everything in this universe, every atom, every ray of light is moving outward in time, away from that core moment, like ripples in a pond. Now do you see it? Our universe isn't falling into something, it's emerging from something. The singularity isn't in front of us, it's behind us. The black hole didn't swallow us, it gave birth to us. Let that sit with you for a while. Let it ripple out. And now, let's turn our gaze to something that used to frighten people, the idea that black holes destroy information. If you throw something into a black hole, a planet, a spaceship, even a book, where does the information go? For decades, scientists believed it was lost forever, burned up, forgotten. But then something amazing happened. They realized that black holes don't destroy information, they encode it. The information about what fell in gets smeared across the event horizon, written in a kind of cosmic code we can't yet decipher. And when the black hole evaporates, that information leaks back out. If we are inside a black hole, then maybe we are that information. Not erased, not ruined, just reorganized, expressed differently, given form. That's a hopeful idea, don't you think? That nothing is ever truly lost, that even in the deepest dark, meaning survives. Now let's glide toward a quieter patch of space. No galaxies here, no stars, just darkness. But even here, there's energy, virtual particles popping in and out of existence. A faint hiss of creation. The universe is never truly still. Even in the quiet, something moves. And this too might be because we're inside a black hole. Inside, nothing ever really stops. The geometry itself forbids it. Movement is written into the walls. You might be wondering now, how could we ever prove this idea? How do you prove you're inside something when you can't see the outside? That's the beauty of it. We don't need to see out. We just need to study the patterns in here. The way light bends, the way time flows, the way matter arranges itself. And over, those patterns whisper the same thing. This universe is curved. This universe is expanding. This universe is finite, but unbounded, just like the inside of a black hole. So maybe we're not trapped. Maybe we're nestled. Maybe we're not falling. We're rising, blooming outward from a singularity, petals of space unfolding in every direction. We've come a long way already, drifting through the folds of a universe that might not be outside something, but inside something else entirely, inside a black hole. That idea isn't just hanging in the air anymore, it's settling in, like cosmic dust, collecting in the corners of your thoughts. Let's keep following it, you and I. Look up, not toward a ceiling there isn't one, just upward in your mind, toward the place where the galaxies thin out and the night gets deeper. Picture a black hole again, just for a moment. Not as something dangerous, not as a monster hiding in space, but as a tunnel. Not a tunnel you pass through, a tunnel you're born in. A tunnel that doesn't lead to anywhere else. Because it is the place, the inside, the destination. That's what we might be inside now. Not next to, not orbiting around, not heading toward, but inside already, and always have been. Now hold that in your thoughts, and let's glide forward. The stars around us are older than words. Some are so far away that the light reaching our eyes right now began its journey before humans learned how to write, before our planet had trees, before the moon had craters. And yet, the light still comes. Let that sink in. This light, this shimmering wave across space, has been traveling for billions of years, only to fall softly onto your imagination here and now. That's the scale of things in the universe. That's the tempo. And it's the tempo we'd expect inside a black hole, too. Because in here, space and time aren't separate things. They're part of the same cloth, a four-dimensional fabric that stretches, warps, folds. It's this very fabric that defines the shape of our universe. And in the deepest part of a black hole, that fabric doesn't tear, it transforms. Now imagine with me, what if that transformation was the birth of a whole new space? We often think of black holes as ends, but here, maybe they're beginnings. Maybe they're places where time flips, where collapse turns into creation, where an ending becomes a universe. And maybe we're the result of one of those flips. Let's feel the expansion now. Not just watch it, but feel it. The galaxies aren't just moving away from us, they're being carried away by space itself, like raisins in rising dough. The dough doesn't stretch because the raisins push. The raisins move because the dough expands. Now think about this. If the universe were truly infinite, there would be no edge, no limit to the galaxies. But what we see has a shape, a temperature, and boundaries, not physical walls, but informational horizons, places beyond which we cannot see. And that's what you'd expect inside a black hole. The event horizon becomes the outer limit of what can ever be known. Not a prison wall, just a horizon. A line we can never cross, but one that still defines the world we live in. Feel that? That slow awareness settling into your thoughts? That's the realization that space is not empty. It's full of movement, of energy, of invisible patterns. Every patch of vacuum is teeming with virtual particles, borrowing energy, flitting in and out of existence, and that churning chaos beneath the calm, that's what gives rise to everything. And it too matches what we'd expect if we were inside a black hole. Now glide with me past a spiral galaxy, arms stretching out like a dancer turning slowly in the void. There's a black hole in its center, massive, silent, heavy with memory. If we could look inside, truly see, we might find something unexpected. Not death, but a cradle. Not silence, but complexity. Black holes have a surface area, a temperature, an entropy. That means they hold information. That means they remember. Every bit of matter that falls into them changes them, adds to their surface, shifts their balance, increases their entropy. And remember, the holographic principle says that all the information inside can be encoded on the surface. So maybe our universe, too, is encoded. Maybe the edge we see, the horizon of the visible universe, is a kind of information shell. Not a wall, but a skin. Not solid, but essential. You might feel small right now, hearing this, but you're not. You're part of the structure. You're made of the same ingredients that shaped galaxies and formed stars. Hydrogen, carbon, oxygen atoms forged in the cores of ancient stars that died long ago and spread their remains into space. Everything you are was once stardust. And if that stardust came from a star, and that star came from a universe, and that universe came from a black hole, then you are part of an unbroken chain of transformation stretching back to the edge of time itself. Let's turn now slowly, peacefully toward the idea of scale. Our universe contains at least 2 trillion galaxies, each with billions of stars, and around many of those stars, planets, rocky, gaseous, icy, molten, some with atmospheres, some with storms that last for centuries, some with moons so smooth they shine like glass. And all of it fits inside the expanding interior of our space. If we really are in a black hole, That means its mass, its energy, its entire interior volume is all contained in what we call the universe. And the laws that govern this space, gravity, motion, light, chemistry, are the laws that emerged because of that black hole's geometry. This isn't metaphor, it's math. The equations line up, the thermodynamics match, the entropy values are consistent. And more, the idea that we are inside something, not just surrounded by emptiness, begins to feel less like fantasy and more like clarity. You don't need to be a physicist to feel this truth settling into you. Just listen, just drift. You and I are not falling into darkness. We're expanding into possibility. Inside this bubble, time moves forward, light travels, galaxies form and scatter. But from the outside, if anyone could look, we might appear frozen, suspended just inside the horizon of some larger universe's black hole. They would never see us fall. To them, we'd be paused at the edge. But inside, time flows like a gentle river, and we are caught in its current. That's where we are, right now, always. And the fact that we can ask these questions, that we can sit here together and gently wonder if our entire reality is the inside of something else, is the best evidence we have that it might be true. Because wonder itself is a kind of gravity. It pulls us deeper. It holds us close. And right now, I'm glad to be floating with you. You're still with me. I can feel it. That quiet curiosity, sitting gently beside us like a companion star. Thank you for sticking around. And hey, just before we go further, if you like listening to quiet stories about space and stars, please tap the like button. It helps others find this peaceful place too. And if you want to come back for more calm journeys through the universe, please like and subscribe. Enjoy what I do here, and let me know in the comments where you're tuning in from and what time it is for you. It's always fascinating to see who's joining us from around the world. Hey everyone, today we're looking into stars, but now we're going deeper than ever, into the space between stars and what might be underneath it all. Picture this. You and I are floating in deep space again, above no particular planet, past no particular galaxy, just the dark stretch between clusters. There's a hush here that even photons hesitate to disturb. The nearest star? Maybe 100,000 light years away. The nearest noise? Maybe none, ever. But this silence hides something strange. Because everywhere we look, in every direction, the universe is expanding. That's not poetic. It's measurable. The farther away a galaxy is, the faster it's receding. This is called Hubble's law. Edwin Hubble discovered it in the 1920s by observing redshifts, the stretching of light caused by motion. The more stretched the light, the faster the galaxy is moving away. The pattern was clear: expansion. Now let's float gently backward in time. If the universe is expanding, then in the past, it was smaller. Compress it far enough, and you reach a moment we call the Big Bang. But that phrase is misleading. There was no bang, no explosion, no sound, just space itself, rapidly stretching. The term physicists prefer now is cosmic inflation. Inflation theory, proposed in the 1980s by Alan Guth, says that in the very first fraction of a second, around a trillionth of a trillionth of a trillionth of a second, the universe expanded faster than the speed of light. That's not a violation of physics, because space itself can expand faster than anything can move through space. And here's the thing, this rapid expansion, it looks very similar to what we'd expect to see if our entire universe were the interior of a black hole. Let's stop and gently consider that. A black hole forms when a massive star collapses under its own gravity. Its core compresses into a point of near-infinite density, what we call a singularity. But here's where it gets fascinating. General relativity doesn't forbid something else from happening there. Some solutions to Einstein's equations show that a singularity might bounce. Instead of forming a point of infinite collapse, it could tunnel like a pinch in the fabric of space-time and form a whole new expanding region on the other side. That region might become a universe. And this bounce idea? It has a name: white hole cosmology. A white hole is a theoretical reverse of a black hole. Instead of pulling matter in, it pushes matter out. And some physicists think the Big Bang was just that, the birth of a universe inside a black hole, expanding outward from the inside of a bounce. That means that what we see as our Big Bang might have been the moment our parent universe collapsed into a black hole. You're not just floating beside me now, you're floating inside a theory, one that fits the data. Now reach out with your thoughts and feel the cosmic microwave background, or CMB. It's a whisper of ancient light, coming from every direction, left over from the moment the universe cooled enough to let light travel freely about 380 years after the Big Bang. We've measured it with incredible accuracy, and it's astonishingly uniform. The temperature across the entire sky varies by less than 1 part in 100, 0. That kind of smoothness is exactly what you'd expect if the space inside our universe had been stretched in a very specific way, like what inflation, or a black hole interior, would do. More facts? Alright, let's talk about the observable universe. Right now, the part of the universe we can see is about 93 billion light-years across. That's not because the universe is 93 billion years old, it's because space has been expanding while light travels through it. Space stretched out so much that photons from the Big Bang have only just now reached us, even after 13.8 billion years of travel. And that visible edge? It acts a lot like the event horizon of a black hole. That's the next big fact to wrap your mind around. When you look far enough away, you're not just looking at distance, you're looking at time. And eventually, you hit a limit where light hasn't had time to reach us since the beginning of the universe. That's our cosmic horizon. But if we're inside a black hole, that horizon takes on a deeper meaning. It means we can't see outside, not because it's dark, but because time itself bends inward, like a funnel. All paths curve back into the center. From inside a black hole, no signal ever escapes beyond the horizon. The geometry matches what we see in our universe. Let's spiral closer to the information paradox now. This one's juicy. When matter falls into a black hole, what happens to the information that describes it? Is it lost? That would violate the rules of quantum physics. Stephen Hawking famously said that black holes destroy information. But later, with others like Leonard Susskind, he proposed a new view. The information isn't lost, it's stored on the surface. This idea led to the holographic principle, one of the most mind-bending concepts in modern physics. It says that everything inside a region of space, every particle, every movement, even you, can be fully described by information stored on the surface of that space. So if we're inside a black hole, all the information about our universe might be encoded on its event horizon, a two-dimensional shell describing a three-dimensional world. Imagine that. We are the projection, the shadow, the flickering hologram on the surface of a deeper reality. Now breathe. That was a lot, I know, but you're handling it beautifully. You and I are just floating gently, surrounded by facts that swirl like nebulae. No urgency, just discovery. And there's more. The entropy of the universe, the amount of disorder, increases with time. That's the second law of thermodynamics. But it also increases with surface area, not volume. That's exactly what black holes do too. Their entropy grows as their event horizon grows. Not how much is inside, but how big the boundary is. That's another clue. Our universe behaves like a black hole from the inside. It has a finite amount of entropy, a measurable temperature, a limited horizon, and it expands in a way that suggests it came from a highly curved, incredibly dense beginning. Now let's float past that idea for a moment and just look. Look out at the universe with me. Stars exploding, galaxies merging, clusters forming filaments across empty voids. It's not random, it's patterned. And those patterns match the initial ripples from inflation. They match what we'd see if a bounce created us from a collapsing core. And we haven't even touched quantum gravity, or loop cosmology, or the idea of baby universes budding off from black holes like seeds in a garden. Let's turn quietly now, drifting through a patch of deep space that feels untouched. There's a kind of gentle pressure here, not like wind, but like space itself is curved. You can't see it, not directly, but you can feel it if you slow down and just notice. Planets orbit stars. Stars orbit galactic centers. Galaxies themselves bend toward invisible masses. And all of that bending, that graceful dance, it's the result of something Einstein taught us. Let me tell you a fact that shapes everything we see. Gravity isn't a force. Not like magnetism, not like a rope pulling a weight. Gravity is the bending of space and time. It's the shape of reality itself. And when enough matter is packed into a small enough space, that bending becomes so extreme, so sharp, That space curves inward, completely trapping even light. That's when we call it a black hole. And here's a key thing. Black holes don't just pull things in, they reshape time. From outside, time near a black hole's edge, the event horizon slows down dramatically. It's not just an illusion. A clock falling into a black hole really does tick slower to someone watching from far away. From the clock's own perspective, though, everything feels normal. So here's something curious. If we're inside a black hole, and time out there has slowed compared to us, then that could explain why we see the universe evolving the way it does. Maybe what looks like expansion to us is just the shape of space folding outward in time. And that brings us to loop quantum gravity. I promise this won't get technical. Just stay with me here. In loop quantum gravity, space itself isn't smooth. It's made of tiny loops unimaginably small, like a fine mesh or web, and time moves in discrete steps. In this theory, the Big Bang wasn't the beginning, but a bounce, a contraction that shrank until space became too dense to squeeze any further, then rebounded outward. The mathematics of that bounce are eerily similar to the behavior of a collapsing star that forms a black hole. So again, we're circling that idea. Our universe might not be the outside of something, it could be the inside. And if we are inside a black hole, then we have to rethink what black holes are. Here's another juicy fact. Stephen Hawking predicted in 1974 that black holes aren't completely black. They emit tiny amounts of radiation called Hawking radiation because of quantum effects near the event horizon. This radiation slowly drains the black hole's mass until eventually, in a time far longer than the age of the universe, it might evaporate entirely. But what happens to the universe inside the black hole, if it has one? Does it vanish when the outer black hole evaporates? Or does it keep expanding, unaffected by the parent black hole's fate? We don't know. But one proposal called the black hole cosmology model suggests that every black hole gives birth to a new universe, a baby universe, that the collapse from one side becomes expansion on the other, like a throat connecting two realities. You and I are now drifting near the idea of multiverse black hole reproduction, and yes, that's a real hypothesis. It goes like this. Our universe might not be alone. It might be one of many, perhaps an infinite number, each born inside its own black hole, each with slightly different physical laws. Over time, universes that produce more black holes reproduce more often. In this way, cosmological natural selection happens. And guess what? Our universe is exceptionally good at making black holes. Stars die and collapse into them all the time. Galaxies gather around supermassive ones. Maybe that's not a coincidence. Maybe it's evolution on a cosmic scale, survival of the bounciest. Let's float closer again, to something called the Planck scale. It's a tiny, tiny size, the smallest scale we think exists, where quantum effects dominate and the usual rules of space stop making sense. Below this scale, space is fuzzy, stormy, alive with popping particles and turbulent loops. This is the realm where gravity and quantum mechanics must work together. And black holes reach this realm in their centers. The singularity, that's where space-time breaks down, according to general relativity, but quantum gravity might smooth it out. Instead of a point of infinite density, we might have a bridge, a Planck star that resists total collapse, a quantum bounce. And if a bounce happened, then what looks like a singularity from one side, the outside, might actually be the start of a new expansion on the other. A new universe inflating rapidly, time unfurling, stars forming, planets spinning, and someone, somewhere, asking the same question we're asking right now. Are they inside a black hole too? Take a breath here. It's a lot, but it's beautiful. You and I just floating, thinking about how black holes, instead of being dead ends, might be cradles of creation, how the place we call home might be a hidden valley inside an older, grander cosmos, and how, even now, our own black holes might be giving birth to others. Now tilt your head and notice the shape of space, not just empty distance, but curved geometry. Look at the way galaxies are arranged, not randomly scattered, but strung together like beads on filaments. This web is called the cosmic large-scale structure. It stretches for hundreds of millions of light years. And the patterns we see today began as tiny ripples in the early universe, amplified by gravity and the slow pull of dark matter. Those ripples, they might trace back to quantum fluctuations, random little bumps that happened during inflation. If we're inside a black hole, then those fluctuations were part of the bounce little echoes of what came before. And maybe, just maybe, those echoes came from a parent universe with its own stars, its own civilizations, its own moments of wonder. Maybe someone else once asked, "Are we inside a black hole right now?" And now we're the answer. Now close your eyes for a moment, or just soften your gaze. Picture the starlight bending gently above your head. See how the faint, scattered galaxies shimmer through the dark, like dew caught in a spider's web. That web stretches in all directions, but it's not flat. We're drifting through a space that curves softly under us, a cosmic valley in an invisible hill, and that curve is everything. Let your mind wander for a second. You feel how the galaxies are moving away from us, all of them, in every direction, like we're sitting at the center of an expanding balloon. But here's a fact that will stir something deep in your chest. From every galaxy in the universe, it looks like the universe is expanding away from them too. This isn't just our special view, it's everyone's. That's because space itself is expanding, not just the stuff inside it. If you could stretch a sheet of rubber and sprinkle glitter across it, the glitter would move apart as the sheet grows. No one piece is in the center. The expansion happens everywhere at once. Now, if you're wondering what this has to do with black holes, stay close. We're almost there. There's something called a cosmic event horizon, not the one around a black hole, but one that belongs to the whole universe. Because space is expanding faster, the farther out you go, there's a limit to how far light can ever reach us, even if we waited forever. Beyond that horizon, galaxies are slipping away faster than the speed of light, not because they're moving through space quickly, but because space itself is stretching faster than light can travel through it. Sound familiar? That's exactly what happens inside a black hole. From the point of view of something falling into a black hole, they never quite reach the center, not in any way we can see. They vanish behind a horizon, and to us, it's like they've frozen in time. But to the thing falling in, time continues. They fall and experience the inside, a journey we can't see from out here. That's what makes this idea so mesmerizing. What if the Big Bang wasn't an explosion in space, but an explosion of space from inside a horizon? What if it was the other side of a black hole? And what if we're still in there? Feel that silence around you? That slow drift? You're not just floating through space now, you're floating through a question, one that touches everything. Let's pull in closer to a fascinating detail, the cosmic microwave background. It's a faint glow that surrounds us in every direction, a whisper from the early universe, from a time about 13.8 billion years ago when everything was hot, thick, and glowing. Today, it's cooled into a gentle radio wave hum, but it still carries fingerprints of how our universe began. The remarkable thing? That glow is perfectly even in all directions. Almost. There are tiny, tiny ripples like 1 part in 100,000. And those ripples are the seeds of everything we see today. Stars, galaxies, planets, you. And here's where it gets wonderfully weird. If we were inside a black hole, we'd expect some of these same effects. The extreme curvature of space, the way time and energy behave near the beginning, all of it lines up with what we see in this glowing background. In fact, several cosmologists have tried to map black hole physics directly onto cosmic expansion, and the match is eerily close. You might be feeling it now, that tug in your chest, that mix of awe and something like vertigo. You're not just floating through the stars, you're floating through a theory of everything. And the deeper you go, the more it holds together. Here's something else to hold in your palm as we drift. Singularities, those supposedly infinitely dense points at the center of black holes, might not be infinite at all. That's just a sign that our current equations break down. Nature, it seems, doesn't like infinities. And newer theories, like loop quantum gravity and string theory, suggest that space and time bounce instead of collapse. So maybe instead of falling into a bottomless well, matter and energy get compressed until they rebound, like pressing a spring tighter and tighter until it leaps back. That leap could be what we call the Big Bang. Now listen closely, not with your ears, but with that quiet part of your mind. Can you hear it? The hum of cosmic history? Every galaxy we see is a kind of echo. Every atom in your body was once part of a star, and every heartbeat you've had was made possible by the gentle structure of space-time itself, the very fabric we're floating through right now. So if this really is the inside of a black hole, What does that mean for us? It means the universe has a boundary, a horizon beyond which we cannot see or reach. But that doesn't mean it's a prison. It means we are inside something ancient, enormous, and still full of possibility. It also means something incredibly hopeful. Because if black holes can lead to new universes, then nothing, not even death or collapse, is truly the end. The cosmos doesn't waste. It recycles. It transforms. It creates. Look around again. The stars haven't changed, but maybe we have. So take a breath with me. Float here, in the middle of the unknowable. You and I, inside a question shaped like the night sky. Picture yourself floating gently in a darkened room, the glow of distant galaxies filtering through the cosmic dust like shards of forgotten light. Reach out and feel the faint warmth of a newborn star nearby, so young that its light hasn't quite escaped the nursery cloud around it. Listen to the quiet hum of cosmic dust gathering, swirling into shapes that will someday become planets, moons, maybe even life. Now, here's a fascinating fact to tuck into your mind's pocket. Black holes aren't just dark holes swallowing everything. They're also intricate dancers of gravity and light, bending and warping space and time around them. Their edges, called event horizons, are like invisible boundaries, beyond which the rules we know seem to shift and blur. What's truly mind-bending is that the mathematics describing black holes, those strange, dense spots where gravity wins in a big way, also describe our entire universe on the largest scale. The same equations that tell us how time slows near a black hole's edge also describe how our universe has been expanding since the Big Bang. Imagine that. The universe might be something like a black hole turned inside out, or maybe we are sitting safely inside a gigantic black hole, looking out into what we call space. This idea isn't just wild speculation. It's supported by the very way the universe behaves. Take the cosmic microwave background, that faint glow left over from the hot, dense beginning of everything. Scientists have studied this light with incredible precision. They found it to be remarkably uniform, which tells us the early universe was smooth and evenly spread out. But there are tiny fluctuations, ripples, just enough to form the structure we see today. Galaxies, stars, even you and me. Now here's a thrilling fact. The shape and distribution of those ripples fit perfectly with what you'd expect if our universe had properties similar to the inside of a black hole. The bending of space and time, the cosmic horizon beyond which light can't escape, and even how energy behaves near the beginning all echo what black hole physics predicts. Let's glide closer to the core of this thought. If our universe is a black hole, then it has a boundary we can't cross, a cosmic event horizon just like smaller black holes do. That horizon limits what we can see and interact with. Beyond it, the universe might stretch endlessly, or perhaps something else lies there, other universes, other realms of space and time. But here's the truly heartwarming part. Being inside a black hole or something like it doesn't mean we're trapped or doomed. Instead, it might mean we are part of a cosmic cycle. Black holes could be doorways to new universes, new beginnings born from the collapse and rebound of matter and energy. Picture a star collapsing under its own weight, shrinking smaller and smaller until it forms a black hole. At the heart of that black hole, where we expect a singularity, a point of infinite density, new physics might take over. Some theories suggest that instead of crushing everything into oblivion, the black hole might bounce, starting a fresh expansion. That bounce could be the Big Bang that began our universe. Feel that swirl of wonder as you float through this idea. Every atom in your body, every heartbeat, every breath is connected to that cosmic dance. The iron in your blood was forged in the heart of an ancient star. The energy in your cells traces back to the earliest moments of cosmic expansion. Reach out and imagine touching the fabric of space-time itself. Not a cold, stiff cloth, but something flexible and alive, shaped by gravity and the flow of energy. This fabric stretches, bends, and sometimes folds, creating the shapes we call stars, planets, and galaxies. Now, listen carefully to this. Black holes are not just destructive, they're also creative. They recycle matter and energy in mysterious ways. When a black hole evaporates through a process called Hawking radiation, it slowly loses mass, releasing particles and energy back into space. This process takes an unimaginably long time, far longer than the current age of our universe, but it's a subtle reminder that black holes are not eternal prisons. And here's a spectacular fact. The universe itself might have its own Hawking radiation, a kind of gentle glow from the cosmic horizon. Scientists call this the Gibbons Hawking effect. It suggests that even the universe's horizon can emit particles and energy, much like a black hole's event horizon. Imagine drifting closer to that cosmic horizon, feeling the warmth of that faint glow. It's a reminder that the boundaries of our universe are alive with subtle energy, whispering secrets from the edge of everything we know. Let's think about time now, that ever-flowing river we all ride. Near a black hole, time slows down dramatically for an outside observer watching something fall in. This is why someone falling into a black hole appears frozen in time at the event horizon from our point of view. But inside, their experience of time continues uninterrupted. Our universe might share this property. The Big Bang could be a kind of horizon in time, a starting point beyond which we cannot look. Time flows forward from that moment, expanding with space itself. Imagine time as a gentle wave, flowing endlessly from the Big Bang horizon. The farther out you go, the more stretched and expanded it becomes. This stretching is what makes distant galaxies seem to race away from us faster than light, not because they're speeding through space, but because space itself is stretching. You might notice now how this connects to the idea of cosmic inflation, a period shortly after the Big Bang when the universe expanded exponentially fast, growing from a tiny speck smaller than an atom to something vast and sprawling in the blink of an eye. Inflation smoothed out the wrinkles in the early universe and set the stage for the cosmic microwave background's gentle glow. It's as if the universe took a deep, cosmic breath and then began the slow, graceful dance of expansion we witness today. Now imagine you're not just a passive observer, but an active traveler, riding the waves of space-time. Feel the subtle tug of gravity as it shapes your path, curving your trajectory around unseen masses and dark matter halos that cloak galaxies like invisible scaffolding. Dark matter, by the way, is another cosmic puzzle piece. It's invisible. It doesn't emit or absorb light, yet it makes up about 85% of the matter in the universe. We can only detect it through its gravitational pull on visible matter. Picture the universe as a vast web of dark matter filaments, with galaxies sprinkled like luminous pearls along its threads. This web gives the universe its large-scale structure, a cosmic tapestry woven from mystery and light. And what about dark energy? That's the mysterious force pushing the universe's expansion to speed up, rather than slow down as gravity would suggest. It makes up about 70% of the universe's total energy. Imagine a gentle pressure, invisible but relentless, stretching space and time apart faster and faster. This expansion pushes galaxies beyond each other's reach, creating horizons beyond which communication is impossible. In fact, the expansion of the universe is accelerating right now, and that means the cosmic event horizon, the boundary beyond which light can never reach us, is shrinking. Our observable universe is getting smaller in a sense, because fewer and fewer distant galaxies remain within reach. This fits intriguingly with the black hole analogy. Black holes also have horizons, and as they lose mass through evaporation, their horizons shrink. So, could our universe be a black hole with an event horizon that's growing and shrinking in time? Or maybe the event horizon is a dynamic place, responding to changes in dark energy and cosmic matter. It's humbling to realize that these grandest mysteries intertwine: black holes, cosmic horizons, dark matter, dark energy, all part of a cosmic dance that defines our reality. Let's settle deeper into this cosmic flow. Feel the silence around you. In that silence, there's a quiet hum, the echo of creation, of expansion, of time itself stretching out ahead. You and I, floating in the middle of everything, inside a universe that might itself be a black hole. A universe born from a bounce, a cosmic spring unfolding, expanding, and singing its slow, eternal song. Take a deep breath. Let the wonder settle in. Let's keep drifting together, your presence beside me like a steady star in this vast night. Feel the gentle pull of gravity, now not a harsh force dragging you down, but a soft shaping of space and time, like a slow dance. Black holes aren't cosmic vacuum cleaners sucking everything indiscriminately. Instead, they are precise sculptors of gravity, their influence bending paths, and light like a master painter, bending strokes on a canvas. Here's a fact that might surprise you. Black holes come in many sizes, from tiny, primordial black holes possibly formed just after the Big Bang, to stellar black holes born from collapsed stars, to the giants called supermassive black holes, millions or even billions of times the mass of our Sun, resting at the centers of most galaxies, including our own Milky Way. Our galaxy's heart holds Sagittarius A, a supermassive black hole quietly sitting 4 million times heavier than our Sun. Even though it's invisible, we can detect its presence by watching stars dance in tight orbits around a seemingly empty spot, moving with wild speed and precision. These movements give us strong evidence that the black hole there isn't just a theory, it's real, a colossal anchor in the galaxy's vast ocean of stars. Picture yourself now drifting on a gentle cosmic breeze, the faint glow of distant galaxies shimmering like fireflies in the dark. Notice how the universe seems to stretch endlessly every direction, opening up into more space, more stars, more mysteries. But here's a curious thought. What if the universe's expansion itself is shaped by the gravity of something bigger, something invisible surrounding us? Some scientists suggest the entire universe could be a giant black hole, not the kind that traps us forever, but one that contains everything we see and everything we are. Feel the quiet hum of this idea. It's not claustrophobic or scary. Instead, it's a cozy cosmic shell, wrapping us in space-time, holding the rules of physics that shape our reality. Here's a fact that might help. Inside a black hole, the pull of gravity is so intense that it warps space-time itself. Time slows down, space bends, and nothing can escape beyond the event horizon. Now, our universe is expanding, galaxies speeding away from each other like spots on an inflating balloon. This expansion was first discovered in the 1920s, and it's been speeding up in recent times due to a mysterious force called dark energy. If we imagine the universe as a black hole, then this expansion might be the natural stretching of space-time inside its horizon. Think of the event horizon as a cosmic boundary, and we're inside it, gently moving outward, carried by the flow of space itself. The shape of the universe, whether it's flat, open, or closed, gives clues about this idea. Current measurements show our universe is nearly flat, but with a tiny positive curvature. This subtle curve is what you might expect inside a giant black hole, where space-time bends just enough to hold everything together. Imagine standing on a vast cosmic hill, looking in every direction, and noticing the gentle curve of space beneath your feet. Another fascinating fact: black holes have entropy proportional to the surface area of their horizons, not their volume. That means the information or degrees of freedom of a black hole scales with its boundary. In cosmology, the observable universe also has an entropy linked to its horizon, the cosmic event horizon created by expansion and dark energy. Feel that mysterious connection as you drift through space, the universe's horizon, carrying secrets about the cosmos's total information content, just like a black hole's edge. Now, you might wonder what happens if we cross the event horizon of this cosmic black hole. Would we notice? That's the thing, if the universe itself is a black hole, we are already inside it. The horizon isn't something we cross, but the very boundary shaping our observable world. Inside this boundary, time moves forward, stars are born and die, galaxies swirl, and life emerges, all dancing to the rhythm of gravity and quantum fields. Here's another intriguing fact. Inside black holes, space and time switch roles. Outside, time flows steadily, and space extends around us. Inside, moving forward in time means moving closer to the singularity. If our universe is inside a black hole, the Big Bang, the beginning of time and space as we know it, might be the moment we crossed into this cosmic interior, the birth of our universe from a collapsing star in a parent cosmos. Picture the Big Bang not as a distant explosion, but as the entrance to this black hole's interior, a tunnel where time and space unfurled into the vast cosmos we see. That leads to a mind-expanding possibility. What if every black hole in our universe is a gateway to a new universe? Maybe countless universes are hidden inside black holes, each with its own laws, stars, and stories. Reach out with your mind and feel the enormity of this multiverse, where black holes aren't just ends but beginnings, cosmic seeds, planting new realities beyond the veil. Feel the gentle calm of this thought, the universe's endless creativity. Back in our universe, the cosmic microwave background radiation bathes us in an afterglow of the Big Bang, a whisper of that first moment. This faint light is remarkably uniform, yet it carries tiny ripples, seeds of galaxies and clusters, the patterns of matter forming under gravity's influence. The existence of this radiation and its properties supports the idea of a finite, bounded cosmos consistent with being inside a larger black hole. Feel the warmth of that faint glow surrounding you, a cosmic heartbeat pulsing through time. Another fascinating fact: the laws of physics as we know them break down at singularities, places of infinite density and curvature, like the centers of black holes. But modern theories of quantum gravity aim to smooth out these infinities, suggesting singularities might be replaced by bounces or new phases of spacetime. If our universe started inside a black hole, the Big Bang might be such a bounce, a transition from a collapsing phase in a parent universe to an expanding phase in ours. Imagine time folding like a delicate origami, unfolding a new cosmos with every cosmic bounce. Picture yourself floating inside this timeless origami, a witness to the birth of stars, galaxies, and life itself. The more we explore these ideas, the more we see how gravity, quantum mechanics, and information weave together to form the fabric of reality. Our universe could be a hologram projected from a distant boundary, a bubble inside a cosmic black hole, or even a node in an infinite cosmic web. Feel the wonder as your mind stretches across these possibilities, each one a doorway to new questions and mysteries. And through it all, we're here, companions on this gentle voyage, exploring the stars and the hidden depths of space and time. Let your curiosity drift on the cosmic breeze as we keep walking this path together, never rushed, always discovering. Picture yourself gently floating forward, guided by the invisible currents of space-time. You sense time flowing differently here, more fluid, more mysterious. Inside a black hole, the rules we're used to start to twist and change, like walking through a hall of mirrors, reflecting endless versions of reality. One idea scientists explore is what lies beyond the black hole's center, the so-called singularity. Traditionally, this point is seen as a place of infinite density and zero volume, a cosmic dead end. But newer theories suggest the singularity might not be the end instead. It could be a gateway. Feel your mind opening as we imagine that gateway, a passage leading somewhere new, somewhere beyond our current understanding of space and time. Some physicists propose that the singularity might lead to another universe, a baby cosmos born inside the black hole, expanding outward just as ours does. This concept is called a bounce or white hole universe, where matter and energy expelled from a black hole's far side ignite a fresh Big Bang. Imagine drifting through this cosmic tunnel, sensing the expansion and creation of new stars and galaxies beyond the veil. This idea connects with the multiverse concept, countless universes nested inside black holes, each a bubble of creation in an endless cosmic ocean. Another fascinating fact is that black holes evaporate slowly over unimaginable timescales through a process called Hawking radiation. Although this radiation is incredibly faint for large black holes, over billions and trillions of years, a black hole could lose mass and eventually vanish. What happens then? Does the universe inside it collapse? Or does it transition into something else? Maybe the evaporation marks the end of one universe and the beginning of another, a cosmic cycle of birth and rebirth. Feel the gentle rhythm of this cycle, like the beating heart of the cosmos itself, pulsing with endless transformation. Inside the black hole universe, space is warped, and time flows toward the center. But as we move forward, this flow might loop, twist, or open into new dimensions. You might notice that our understanding of dimensions is evolving too. Theories like string theory suggest there could be many more dimensions beyond the familiar three of space and one of time. Imagine reaching out and brushing against these hidden dimensions, feeling their subtle presence shaping the cosmos. If our universe is inside a black hole, those extra dimensions might be part of the bigger space embedding us, adding complexity and wonder. Another remarkable fact: gravity inside black holes and the expanding universe is linked to dark energy and dark matter mysterious components, making up about 95% of all that exists. We can't see dark energy or dark matter directly, but their effects shape the cosmos, pushing galaxies apart and holding clusters together. Perhaps these dark components are clues to the deeper structure of the black hole universe, hints of the unseen realms beyond our cosmic horizon. Feel the presence of these invisible forces around you, gently guiding the dance of stars and galaxies. And as we float through this vast cosmic ocean, it's comforting to realize that the universe, black hole or not, is full of surprises, mysteries inviting us to explore with open hearts and minds. What if, beyond the horizon, new laws of physics await, new possibilities for time, space, and life itself? Picture yourself drifting gently through the fabric of space-time, the faint shimmer of distant galaxies casting a soft glow around you. Imagine the way light bends and curves here, not randomly, but like ripples on a vast cosmic pond stirred by some unseen force. This force is gravity, the invisible hand that shapes black holes and governs the universe's grand dance. Inside a black hole, gravity is so intense that it molds the very shape of reality. But here's a curious twist. What if this immense gravitational pull doesn't crush everything into oblivion, but instead folds the universe in on itself like a vast cosmic origami? Feel the gentle curvature beneath your feet as you drift through this imagined fold. Space and time entwine in ways that challenge our everyday sense of up and down, near and far. This is where concepts like time start to feel more like a path winding through an uncharted forest, rather than a straight line. Now, consider the universe's expansion. Galaxies race away from each other at incredible speeds, pushed apart by what we call dark energy. This mysterious force acts like an unseen wind, stretching the fabric of space itself. Some scientists suggest that this expansion fits perfectly with what we'd expect if our universe were inside a black hole. Feel the pull of this dark energy as it tugs gently at the edges of everything, making space grow larger with each passing moment. What if the Big Bang, the explosive birth of our universe, was actually the moment we crossed into this cosmic black hole? Imagine that initial burst not as a fiery explosion, but as a gateway opening into a vast, mysterious interior. Inside this cosmic shell, time begins to flow differently. Space takes on new shapes, and the rules of physics twist into extraordinary forms. Reach out and imagine touching the boundary of this black hole universe, the event horizon. It's not a wall, but a shimmering veil where light bends and time slows. Scientists tell us that the event horizon holds secret entropy and information encoded on its surface, like a vast cosmic library, cataloging everything within. Imagine this library not as rows of dusty books, but as a glowing hologram, constantly shifting and shimmering with the stories of stars, planets, and galaxies. If we are inside this cosmic library, each star's light and each particle's journey is part of a greater story written in the language of gravity and quantum mechanics. Now, consider the singularity, the core of a black hole, traditionally seen as a place where physics breaks down. But newer ideas suggest it might be a gateway to another universe, a cosmic seed bursting forth to create a whole new realm of stars and space. Imagine traveling through this gateway, entering a new bubble of existence, expanding endlessly outward, just like our own universe did billions of years ago. This opens up mind-bending ideas about multiverses, countless universes birthed from black holes, each with its own unique laws, colors, and possibilities. Feel the vastness of this cosmic garden, each universe a flower blooming in an infinite field of space. Gravity, quantum mechanics, dark energy, and the fabric of space-time all weave together in this grand tapestry. Now, think about what happens as black holes slowly evaporate over unimaginable spans of time through Hawking radiation. Imagine the slow fading of a black hole like the last glow of a dying ember, marking the end of one cosmic story and perhaps the beginning of another. This gentle fading hints at cycles of cosmic rebirth, echoing the rise and fall of universes across eternity. Imagine the pulse of these cycles like the steady beating of a universal heart, a rhythm guiding the endless dance of creation and dissolution. Now, sense the presence of hidden dimensions, spaces beyond our everyday perception that might hold the key to understanding the universe's deepest mysteries. Feel as if you are brushing against these unseen realms, sensing their influence on the fabric of reality. Perhaps our universe's black hole shell is just one facet of a more complex, multidimensional cosmic landscape. Dark matter and dark energy, elusive, invisible components, could be manifestations of these hidden dimensions interacting with our universe. Now, imagine yourself standing at a safe distance from Sagittarius A. Picture the swirling clouds of gas and dust spiraling inward, glowing brightly as they heat up. Feel the power of gravity so strong it traps even light, but from where you stand, it's a breathtaking light. Show a cosmic whirlpool glowing in reds, oranges, and yellows, spinning in silence. This quiet dance of gravity reminds us how the same physics governs smaller black holes and the entire universe itself. The bending of light, the warping of time, and the formation of horizons are fundamental properties, no matter the scale. Here's another fascinating fact. When something crosses a black hole's event horizon, it cannot escape, but it also cannot send information back. That's why black holes seem like cosmic mysteries, swallowing information and locking it away. Yet, this led to one of the greatest puzzles in modern physics, the black hole information paradox. If information can't escape, does it disappear forever? That would break one of physics' fundamental laws, that information cannot be destroyed. Scientists have wrestled with this question for decades, and the answer might again connect back to our universe's nature. Some theories suggest that information might be stored on the surface of the black hole's horizon, a cosmic hologram, if you will. This idea, called the holographic principle, proposes that everything inside the black hole can be described by information encoded on its boundary. Now imagine that same holographic principle applied to our universe. It hints that our three-dimensional world might be described by information on a distant two-dimensional horizon, a mind-bending but elegant thought that challenges how we perceive reality. Feel your mind gently stretching as you take in these ideas. The universe is not just a vast space, but a complex interplay of information, energy, and geometry. Another gripping fact: the temperature of a black hole isn't absolute zero as one might expect, but instead, black holes have a temperature related to their size. Small black holes are hotter, emitting more radiation, while large ones are colder. This counterintuitive feature connects thermodynamics, the science of heat, with gravity and quantum mechanics. Think of a black hole as a strange kind of star, one that doesn't shine with light but glows with quantum particles. And if the universe is a kind of black hole, maybe it too has a temperature, a cosmic warmth pervading everything. On that note, the universe's temperature today is measured by the cosmic microwave background, around 2.7 degrees above absolute zero. It's a faint but uniform glow, like the residual warmth after a cosmic bonfire. Now, drifting through this cool background, feel the gentle pull of curiosity deepen. Every photon you see in the microwave background has traveled billions of years to reach you, carrying stories from the infancy of time. Here's another piece of the puzzle. In a black hole, space and time flip roles inside the event horizon. What was space outside becomes time inside, and what was time becomes space. This switch means that moving forward in time inside a black hole is like moving toward its center. It's unavoidable. So, if we are inside a black hole, the expansion of our universe might be like moving through the inside of this horizon, rushing toward an unknown center, or perhaps a new beginning. Feel the pulse of this idea. It's not a prison, but a journey. Space itself is dynamic, flowing, changing shape as it expands. We are not stuck. We are moving, growing, evolving with the universe. Another thrilling fact: some researchers propose that black holes might not end in singularities, points of infinite density, but instead, quantum gravity effects create a bounce. Matter compressed beyond a critical point rebounds, sending energy into a new, expanding universe. This hypothesis is called a white hole scenario, the theoretical opposite of a black hole that spews out matter and energy instead of swallowing it. Imagine white holes as cosmic birthplaces, and maybe our universe is just one such bubble born inside a black hole from another cosmos. Let that idea swirl gently in your mind. Across the cosmic sea, universes might be nested, like Russian dolls, each inside the heart of a black hole in a parent universe. Picture yourself as a cosmic traveler floating through layers of space and time, an explorer inside an infinite fractal of reality. Now, if we zoom back in, our own observable universe spans about 93 billion light-years across. That means light from the farthest galaxies we see has taken billions of years to reach us. But the universe itself is probably much larger, maybe infinite. Because of the cosmic event horizon, there are parts of the universe we can never see or interact with, hidden forever beyond the horizon's veil. This limitation parallels the event horizon of a black hole Both define the boundary between what's observable and what's unreachable. Feel the hum of that boundary around you, like a gentle wall of silence, holding secrets just beyond reach. Now think about what it means for time inside this cosmic bubble. If our universe has a horizon, then time itself could be shaped by it. The flow of time may be linked to the horizons area, a concept called the thermodynamics of space-time. This connects to the profound insight that gravity might emerge from entropy, the tendency of systems to grow disorder, and information theory. Imagine the universe as a grand information processor, where the geometry of space-time and the flow of time arise from underlying quantum bits, the building blocks of reality. This viewpoint is revolutionizing physics, blending gravity with quantum mechanics in new ways. So, what if being inside a black hole is not a cosmic prison, but an invitation to new physics, new perspectives, and infinite wonder? Reach out with your mind and feel the vastness, the silence, and the endless potential. The universe might be the greatest story ever told, a story written in light, shadow, time, and the gentle curves of space-time. And we are part of it, floating inside, exploring, wondering, always reaching for what lies beyond. Feel how quiet it is now, not the kind of quiet you find in a forest or a snow-covered field. This is a deeper silence, older than any sound. It's the hush that lives between galaxies, where even light takes its time. And here we are, floating side by side, watching everything unfold as though the universe were telling us its story, one slow shimmer at a time. Look around. Do you see how the stars no longer feel like they're out there, but more like they're wrapped around us? Like the whole sky curves inward, gently, softly. That's not your mind playing tricks. If our universe is the inside of a black hole, then space is curved in the most magnificent way. It loops and bends in on itself, not in a sharp corner, but like the soft curve of a balloon stretching from the inside. Drift your fingertips through the invisible fabric of that curve. There's no wall, no edge, just more and more space, and with it, more questions. Because inside a black hole, if this really is one, you don't just fall toward the center. The entire direction of falling changes. Everything, including time itself, bends toward what lies ahead, not below. And here's something that will wrinkle your thoughts in the best way. Time here doesn't tick forward like it does on Earth. Inside a black hole, time might stretch, loop, or even stack like layers of warm blankets. What you feel as now might be 1 billion years from someone else's now. There could be entire galaxies living out their lives, unseen, just a blink away in a different layer of time. Listen to that. The hum of time itself, not ticking, not marching, but rolling, swaying. You and I are drifting through that rhythm now, like leaves caught in a gentle stream. Everything is slower, more deliberate. Now tilt your head toward that faint glow ahead. It's not a star, it's something else. Some scientists imagine that at the farthest reaches of our black hole universe, we might find a wall of light. Not a boundary you can touch, but a horizon of information, the event horizon's echo, projected from the outside. Every event that happens inside might be reflected on that surface like shadows on a lantern. They call this the holographic principle. Sounds like science fiction, right? But it's one of the strangest and most beautiful ideas out there, that everything you see, you, me, the stars, even your memories might be a three-dimensional story playing out from a two-dimensional surface. Now imagine floating beside that cosmic lantern. You press your hand toward the shimmering veil, and somehow, you feel yourself reflected back, not just your shape, but your whole existence, written in gentle ripples of light. It's not cold or mechanical. It feels like belonging, like the universe has remembered you. And then you hear something soft, almost like music. Not sound, not exactly, more like patterns. The pulse of atoms forming stars, the swirl of galaxies shaping themselves around dark matter, the faint sigh of a universe aging slowly across eons. If you listen long enough, it begins to sound like a lullaby. Stay close now. I want to show you something even stranger. Let's drift deeper into the current of thought that says our universe isn't just inside a black hole, but is the result of one. Picture this. Somewhere, long ago, a massive star collapsed under its own weight. It formed a black hole, just one among countless others. But something unusual happened inside that particular one. It didn't just collapse. It sparked. It grew. That spark may have been the Big Bang as we know it, a singularity blooming not into destruction, but creation. And everything we know, the galaxies, the comets, the colors of dawn, and the feel of laughter, could be the flowering of that cosmic event. Not outside the black hole, but within it. So what happens when we fall toward the center of this space? Well, maybe there is no center, not like a dot on a map. Instead, we keep moving, keep expanding. The singularity isn't behind us or ahead of us. It's in every direction at once, a seed at the heart of every atom. Feel that, the idea that the Big Bang didn't just happen in one place, but everywhere, all at once. A burst so complete that every inch of space, including the one you're floating through right now, carries that original fire in its bones. And if black holes can contain whole universes, maybe we're not the only ones. Look up. That black spot between those two galaxies, what if it's not just empty space, but the mouth of another universe like ours? A little sibling to our own, tucked inside its parent's arms. What stories does it hold? What strange physics? Maybe its stars are made of ice. Maybe time runs backward there, or sideways, or not at all. Let your imagination wrap around that. Whole realities blooming inside other realities, each one unaware of the others, except through the subtle tug of gravity, a secret handshake across dimensions. And through it all, you're still here, floating, wondering, feeling the quiet presence of a universe that might be far more alive and mysterious than we ever dared to think. So here we are, you and I, after all that drifting. We've floated through curved space, touched the shimmer of event horizons, brushed against the skin of time, and imagined a universe folded inside a black hole, like a story within a story. And somehow, you're still here listening, thinking, wondering, maybe even smiling a little at the strange thought that we might be living inside the leftover dream of a dying star. You've felt the stretch of galaxies. You've heard the silence between them. You've looked at the sky with different eyes, maybe eyes a little wider, a little softer. And even though we've wandered far, none of it was really far away. All these ideas, the curves, the folds, the bursts, the echoes, they're right here, tucked inside your imagination. Yours now, to keep, to carry, to revisit on nights when the sky looks too big, or when you feel too small. Because you're not small, not at all. In fact, you're part of something massive and beautiful, something that might be a black hole, or a story, or both. You exist inside space, yes, but space also exists inside you, in your wonder, your thoughts, your dreaming. You've got stardust in your blood and questions in your bones. And whether we're inside a black hole or not, that curiosity of yours, that's the brightest thing in the universe. So take a breath now, a long, slow one. Feel the hush of it, the stillness after the drift. Feel how you've changed, even a little, even just a thought or two. That's what space does to people. It doesn't shout, it whispers. And if you've heard anything during this journey, anything at all, then the stars have done their work. Thank you for being here. Really, thank you for drifting with me across all those cosmic landscapes, for listening to these stories stitched from light and time. If you ever wonder again, are we inside a black hole? You'll know what to say. Maybe, maybe not. But either way, it's a beautiful place to be. Now float back, gently. No rush. Let the stars behind your eyes stay bright. Let your thoughts take their time folding themselves back into your world. And if the night feels a little quieter now, or the sky a little closer, that's just the universe reminding you it hasn't gone anywhere. It's still here, and so are you. Thank you for listening to this story, for drifting through the silence, for wandering alongside me, and for letting your imagination float through the folds of space. It's been peaceful out here with you. Whether you listened all in one go or returned again and again to hear more, thank you. You made this journey real just by being part of it. Wherever you are, whenever you are, I hope the stars feel a little closer now. You're always welcome here. Until next time, fellow traveler.